You know, for so many of us, this was our very first look at programming. That blinking cursor on the friendly blue screen of a Commodore 64, and that simple, pretty forgiving basic language. So, okay, let's dive in and really see what's going on beneath that familiar surface. Basic was just fantastic, right? It was kind of like having a helpful translator right there with you. You type a command in a language that made sense to you, and it would interpret it for the computer. But, any translation takes time and effort. So while BASIC was simple, it was also, well, slow. And it used up a lot of that precious memory. To get real speed, to unlock what the machine could really do, you had to learn to speak its native language, assembly. And just how big of a difference are we talking about? Well, this shows it perfectly. A super simple program to just change the screen color takes up 38 bytes in BASIC. The exact same program doing the exact same thing in assembly, only 7 bytes. That is over 5 times more compact. Now, when you've only got 64 kilobytes of memory to play with in total, that's not just a small improvement, it's a complete and utter game changer. So the question is, how is that even possible?
To get that, we have to go past the translator and talk directly to the brain of the Commodore 64 itself, the legendary 6510 microprocessor. This little chip is where all the real magic happens, where your commands actually become actions.
Okay, so what I love about this is how it splits up what the processor does. On the left, you've got the workbench. These are the tools that you, the programmer, get to use directly. But on the right, that's the control room. That's the processor's own command center. It uses things like the program counter, or PC, to keep track of which instruction to do next, and the stack pointer, or SP, to remember where it put temporary stuff. They basically run the show. But for our first steps into this world, we're just going to focus on our workbench.
And our workbench is, well, it's a little bit sparse. The people who designed the 6510 gave us just 3 little drawers to work with. You've got the main one, the accumulator, we call it A, and then 2 little helpers, X and Y. And here's the catch. Each of these drawers can only hold one tiny piece of information at a time, just 8 bits of data. Literally everything you want the computer to do has to pass through one of these 3 little spots.
So this is the really crucial point to get. These registers, A, X, and Y, are your entire workspace inside the processor. They are tiny, super fast, temporary storage spots. Before you can do anything with a piece of data, I don't care if it's adding numbers, comparing values, or changing a color, you must first pick it up and put it into one of these registers. They are at the heart of every single thing that happens.
Now, before we write a single line of code, we need a place to put it, right? The C64's memory is like a huge grid with over 65,000 little mailboxes, or addresses. Some of these are used by the system, some are for the screen. It's a busy neighborhood. To avoid causing a system crash, we write our code in a designated safe zone, which usually starts at memory address $1000 and goes up to 8000. You can think of it as our own private workshop where we know we won't be getting in anyone else's way.
Okay, let's get to the tools themselves and see how simple this really is. For our first program, we only need 3 commands, and they follow a really simple logic. Step 1, LDA, which means load accumulator. This is how you pick up a value. Step 2, STA, or store accumulator. This is how you put that value down somewhere else. And step 3, RTS, which is return from subroutine. That just means, okay, I'm done now. So you pick something up, you put it down, and you say you're finished. That's it.
And this visual is just a fantastic way to picture it. LDA is like an input arm, reaching into memory to grab a value for you. STA is the output arm, taking the value that's in your register and placing it at a new address. And RTS? Well, that's just the big exit door you walk through when the job's done. It hands control right back to that friendly basic screen.
All right, time to put this into practice with a fun little challenge. Take a look at the C64 screen. You've got the background color and the border color, and they're controlled by 2 totally different memory addresses. So can we write a program to make the border color automatically match whatever the background color happens to be?
So, here's how we're going to solve it using our new commands. First, we use LDA to read from the memory address that holds the background color's value. That command loads the value into our main register, the accumulator. Now, here's the most important rule of the game, what you could call the accumulator bottleneck. We can't just move data directly from one memory spot to another. It has to make a pit stop inside a register first. So once that color value is sitting in our accumulator, our second command, STA, takes it and writes it out to the memory address for the border color. It's just a simple 2-step grab and drop.
And boom, here it is. This is the whole program, just 3 little lines of code. The first command loads the background color value, the next one stores it in the border color address, and the last one just says we're all done here. You run this, and the result isn't just fast, it's instant. The border and background colors are perfectly synced. That is direct hardware control.
So let's put them right next to each other. In BASIC, you type something like poke 53280, peak 53281. And yeah, it's pretty readable, right? It literally says peak at one address and poke that value into another one. But in assembly, we say LDA D021, STA D020. It might look a little cryptic at first, but you're no longer talking to a translator. You're giving direct, lightning-fast orders to the hardware itself.
And this is really why it all matters so much. On these classic machines, with their tiny amounts of memory and slower processing power, this kind of efficiency wasn't just some cool trick for programmers to show off. It was absolutely essential. It was the only way to create those fast-paced games and complex programs that defined that whole era of computing. Every single byte counted.
You know, for an entire generation of programmers, especially here in this part of Europe, the Commodore 64 wasn't just a computer, it was the entry point. It was this affordable, accessible machine that made these really fundamental concepts of low-level programming available to everyone. It was the gateway that launched thousands of careers in tech. So the huge takeaway here is this. Assembly removes all barriers between the programmer and the raw, unmitigated processing power of the 6510. You are no longer politely asking the computer to do something, you are directly commanding the silicon itself to perform an action. And that's real power.
So, we've just seen how to read a value from one part of the hardware and write it directly to another to sync up the screen colors. Now that you've had a little peek at just how direct this control can be, what's the first simple task that pops into your head that you'd want to program? Let us know what you think. Until next time, happy coding!